So again, welcome to the third week, Serpentinization with Stan Keith, Magma Chem. We're looking forward to the conversations as always, and please use up the chat and let's communicate and really try to break this subject down. We'll start with the outline.
Okay, so you heard Tyson's idea of what serpentinite was. Well, this is another take on it. And basically, you throw hot water on a peridotite and you make a serpentinite. Then we'll take a look at the mineralogy of what a serpentinite is. So it's not just about olivine, it's about all kinds of things, especially magnetite. Then we'll look at how the process of serpentinization proceeds and why the physics of that are important to the liberation of the plume products that serpentinization winds up making.
Mm-hmm.
And to keep going with the initial theme of this whole webinar, we're going to bring kerogen in and see how important it is to serpentinization and how effectively you expand the kerogen molecules about 10 to 100 times during the serpentinization process in something called the Serpentosphere, which essentially is the Earth's moho, and now that's thought to be all circumventing most of the planet except at certain rift areas. And then we'll look at how the history of serpentospheric thought came to be.
This one's cool. Mm-hmm.
And then there's, since 2007, people have started imaging the serpentosphere, and that has yielded a lot more than just refraction studies, and that's really cool stuff.
Settings for it?
Yep, tectonic setting for serpentinization, oceanic spreading, continental rifting, alpine collisions, serpentine diapirs, and mud volcanism.
It's pretty cool. The visuals we got on that going from ocean to continent, ocean, South Atlantic in Brazil, and that connection, and then on continent. That's pretty cool.
The important thing there is the thing you're looking at the right is a serpentinite diapir that comes up under a mud volcano. That's one of the main habitats for oil formation. Okay, next. Why is it important? Well, first of all, as I've already alluded to, it has a big thing to do with the origin of oil. Certain classes of mineral deposits, such as the Kupferschiefer, copper, silver, Mississippi Valley types, Tunguska iron deposits, Homestake gold deposits, tie into it. The origin of life ties into it, as Tyson has already alluded to. And it's a mechanism for plate tectonics because it's tectonic grease. Role of heat production, the serpentinization process is exothermic, so it liberates heats, and the rate of serpentinization needs to be factored into any climate change model, which it is not currently being done.
Here we go. It's kind of rapid fire because the reality of it,
a lot here.
We got 90-something slides. But at the end of the day, with what we're doing, and Stan talks about this, just the concept of it, it's kind of like it's a technical paper. It's also a presentation and even a lecture. It's like combining the three and delivering this information as fast and as accurate as possible. We're always looking for feedback, but this one stacked up on us, and we're going to go 30 seconds, a minute, and really get through it.
Well, this is an introduction to further reading.
Right.
There's examination.
10 PhDs that'll drop out of this.
They certainly could.